Alright, so I want to work this answer key with you guys so that you guys are good. So something to have in handy is first a periodic table along with that practice sheet. Hopefully you guys are getting a feel for it. So the first one, I'm going to do the configurations, those electron configurations, because those will take the longest and they're the hardest. I feel like once you've got them, you start finding the pattern to the periodic table. So let's work it. So the first thing is knowing orbital notation. You know what orbital notation is and how it looks. So on this, what we're going to look at, so I'm trying to do the orbital notation for magnesium, atomic number 12. So I'm going to use the system I gave you guys. I'm going to use the periodic table. So I'm going here, I go all the way through the 1s, 2s, 2p, and 3s, and it's all the way full. So I make my note.
Tegan Mead to the band room. Tegan Mead.
I make my note on here that I stop at 3s, and there's 2 electrons in there, okay? Now I know that looks like electron configuration there, and that's what that is, but that's just my note.
Miss Morgan, 7th period, report to room 1066. Miss Morgan, 7th period, report to 1066.
So I start with 1s, 2s, then there's 2p, and 3s. And all of these are full all the way until I get to that 3s. Then I check, okay, there's 2 electrons. So 1, 2.
Jada Bledsoe to the band room.
And that's it, okay? So that's magnesium. So remember, orbital notation is the one with the underscores and arrows. Now, let's move to looking at bromine. I'll do the video. Stay far. Whose class are we in? So you look at bromine. Bromine, atomic number 35. So we go all the way here. I make my note. Bromine is in the 1, 2, 3, 4, 4p, because it's in the p block, 4th row, and it's 1, 2, 3, 4, 5 in. So 4p, 5. So that's where I'm going to stop. I'm going to keep going all the way until I hit the 4p, 5. 1s, 2s, 2p, 3s, 3p, 4s, 3d, 4p. And remember, whenever you're labeling these, label in the middle. So then, all of them's full all the way until I get to that 4p. And then I'm 5 electrons in. Do not forget your 3 sets of rules that go with these configurations. So first,
I'm sorry for the interruption, but
1,
I need any
2,
junior
3,
and senior
4,
that would like to
5.
participate in the Imagine You virtual surgery that's taking place tomorrow to come down to the cafeteria. That's any junior or senior that's in anatomy, AP biology, and forensics.
Alright, then we're going to do number 52, atomic number 52, tellurium. Tellurium is sitting right here. So tellurium is in the 1, 2, 3, 4, 5, 5th row. It's in the P block, so it's 5P, and it is 1, 2, 3, 4 in. So that's 5P4. So same process. I go all the way through the 1s, all the way through the 2s, all the way through the 2p, all the way through the 3s, all the way through the 3p, all the way through the 4s, all the way through 3d, all the way through 4p. I go through the 5s, all the way through the 4d. stop at 5p. So all these up here are full. Let's fill them in really quick. Important thing to note, make sure you get this fill order right. If you are struggling with this, you need to message me. Now here's the important thing, 5P4, and this is where I'm going to be able to check and make sure you're following your rules. Hund's rule, I got 4 electrons. That's 1 up, 1 up, 1 up, then 1 down. Some people will make a mistake and they're going to put 2 here, then 2 there. Don't do that. Don't be the person that makes that mistake. Alright? Alright, so let's go to the next one. Iron. Atomic number 26. Atomic number 26, I stop here. So it's a 4th row D block, which means 3D. Because remember, N equals rho minus 1 for the D. So 3D, 1, 2, 3, 4, 5, 6 N. So it's 3D, 6. 1s, 2s, 2p, 3s, 3p, 4s, 3d. All these are full all the way till I get to my 3d. Alright, I have 6 electrons, so 1, 2, 3, 4, 5, and 6. So that is the correct orbital notation for iron. Then, last one I got is radon. I gave you this one because I need to make sure you know your field order and you know how to work. Well, that's interesting. Alright, back at it. Alright, so number 86. Radon, right here. Radon is in the 1, 2, 3, 4, 5, 6th row P block, which means I will stop at 6P, and it's all the way through, so it's 6P6. Alright, this one's going to be long, you're going all the way through it. I understand you scrub the video to get to it. So 1s, 2s, 2p, 3s, 3p, 4s, 3d, 4p, 5s, 4d, 5p, 6s. This is where the change is. We go to 4f. So 4f. Then we go 5d to finish off in 6p. So this right here is a big one. A lot of students are going to miss that 6s and you're going to jump straight to that 5d. Remember on that periodic table, these guys right here. This is why I use this periodic table. Those blanks remind you. Jump down to the lanthanides and the actinides. These are all the way full.
To the office.
I'm just filling it all up until I get to that 6p. So 6p, 1, 2, 3. I have 6 electrons. 1, 2, 3, 4, 5, 6. And that's the proper orbital notation for radon. Alright, now we're going to break free. And we're going to switch it up now. We're going to change it. When we change this, we're no longer doing orbital notation. Give me the proper electron configuration. Now remember, electron configuration does away with those underscores and those arrows. It makes it a lot faster. So it takes the subshells with the energy levels and it puts the number of electrons as an exponent. So, fluorine, which is right here. There's fluorine. So this is what we'll do with fluorine. Is we start in 1s, I go all the way through, so it's 1s2, 2s2, 2p. That's where fluorine was, is in that 2p, and I'm 1, 2, 3, 4, 5 in, so it's 2p5. Alright. So now we're going to go from fluorine to atomic number 60, neodymium. So here's neodymium down here, and this is why this one's a good one. It's in that F block, so it really checks, make sure you're working good. So you should work through the periodic table, and this, I'm going to show you here on this one what I'm doing. So I start here. This is S block, P block, D block, F block. So I go all the way through, I drive through. So this is the first row, S, it's 1s2, 2s2, 2p6, 3s2, 3p6, 4s2, 3d10, 4p6, 5s2, 4d10, 5p6, 6s2, but then we drop to 4f, and it's 1, 2, 3, 4 in. So 4f4, that's my stopping point. So 4f4. So it's 1s2, 2s2, 2p6, 3s2, 3p6, 4s2, 3d10, 4p6, 5s2, 4d10, 5p6, 6s2, 4f4. So there is proper electron configuration for neodymium. So another good one is jumping from neodymium. I'm going to stay in that F block trend and go with uranium, atomic number 92. Here's uranium. So this is the 7th row, it's F block, so that means it's 5. The energy level is 5. And it's 5F, 1, 2, 3, 4. 5F4. So 5F4, rolling through. 1s2, 2s2, 2p6, 3s2, 3p6, 4s2, 3d10, 4p6, 5s2, 4d10, 5p6, 6s2, 4f14, 5d10, 6p6, 7s2, 5f4. If you're struggling with these, go back and watch those videos. Alright, going to krypton. Krypton will end 1, 2, 3, 4, 4p6. So we'll get 1s2, 2s2, 2p6. That should be up here. 3s2, 6, 4s2, 3d10, and 4p6. Done. Alright, then we're going to Xeon. So Xeon will finish at 1, 2, 3, 4, 5, P6. You should get 1s2, 2s2, 2p6, 3s2, 3p6, 4s2, 3d10, 4p6, 5s2, 4d10, and 5p6. So it gets a little simpler as you get from the orbital notation to the electron configuration. Okay. So let's go now to the noble gas configuration, and this is one that it's honestly a lot simpler than anything else you're going to deal with, but I want to stress a couple of things to you. First, follow the method, tried and true. So let's look, for example, I'm going to do sodium. So here's sodium. Find sodium on your periodic table. Put your finger on it. So here's sodium. You go up a row. Then you go all the way to the noble gases. So neon. Once I do this, I put neon in square brackets. Its chemical symbol. So I will put square brackets, not parentheses. Remember that. Now let me stress to you, that's a capital N, a lowercase e. It does matter. If you give me capital N, capital E, you're 100% wrong. I will count off on that. So here at neon, we now have substituted all the way to that point. So now here is my new starting point at this point here. So that's my new starting point to where now I'm in the third row S and I go one in, so it's 3S1. Done. And that's what you're going to do with all these. Now I want to stress this to you because I don't have this practice problem on here, but I stress it to you in class so it's fair game. What if I gave you a noble gas and asked you to give me a noble gas configuration? So let's say I asked for noble gas configuration of krypton. You can't put krypton in square brackets. Remember the rule. Go up a row all the way to the noble gases. Just because you're in the noble gases doesn't change nothing. You still go up, so argon is what I will use in the square brackets. So let's look at sulfur. Let's do sulfur now. So I put my finger on sulfur, go up a row, go all the way over. I'm still using neon. But this time I go all the way through the 3S, so it's 3S2. Then I go into 3P, but I'm 1, 2, 3, 4 into 3P, so it's 3P4. Now, let's do germanium. Germanium, put your finger on it. It's atomic number 32. Move your finger up a row, go to the end. Once you get to the end, you will see that we are going to use argon. So after argon, we now have our starting point right before potassium. So that's 4s2, 3d10, because I go all the way through the 3d, into the 4p, and germanium is 1, 2. 1, 2, places in, so that's 4p2. Alright, let's do platinum. Ooh, platinum's a good one. Platinum. Put your finger on it, go up, all the way to the end. Xeon, so XE. So do XE, now change, so I'm at 6, the 6th row, so 6s2. 4F14. Don't forget that F block. After that 6S. After the 6S, it tells you go to the F block. 4F14. And we're going 5D. And I am 1, 2, 3, 4, 5, 6, 7, 8 in. So 5D8. Alright, now I'm going to look at technetium. Technetium's go up one all the way to the end. It's krypton is my noble gas, so Kr. Now I'm starting with the 5th row. So 5s2, 4d, and technetium is 1, 2, 3, 4, 5n. So it's 4d5. So that's how you get those answers on there. That is the answers for the electron configurations. I'm working through all of them. So on the other side, I want to flip over now. And I want to work here on these. This side that deals with the quantum numbers. So first thing I want to deal with is this one up here at the top. So I want to know, can these set of quantum numbers exist? Yes or no? And I'm going to do something for you. Today, when we practiced these in class, all of you struggled with this idea. You kept trying to use this thing. This is what I want you to do. I want you to turn your periodic table over and set it down to the side. And don't touch it until I tell you to. Because when you're determining whether or not these 4 sets of quantum numbers can or cannot exist, you don't use that information. You use the ranges. So the possible ranges for these quantum numbers. So remember, for the principal quantum number n, it was 1 through 7, and it had to be a whole number. For L, it's a range of 0 to n minus 1. Whatever n is, whatever I give you. Then m sub L was from a range of negative L to positive L. So as long as it falls in that range of whatever L is, then m sub s can only be plus 1/2 or negative 1/2. Don't touch your periodic table. Don't look at your periodic table. Can these or can these not exist? It's that simple. So let's start going through and checking them. So n on this first one, n is 4. Can n be 4? Yes. It's 1 to 7. Falls in that range, and that's a whole number. So that's a check. L is 4. Can L be 4? No, L cannot be 4. Why can L not be 4 in this case? Because n is 4, and L can only be 0 to n minus 1. So 4, so that n right there, that's where I'm getting this 4 from. That's what n is. 4 minus 1 is 3, so the highest L can be is 3. So this first set is no, it cannot exist. Alright, let's move to the next one. 5. Can n be 5? Yes, it's a whole number between 1 and 7. If n is 5, L can be from 0 to 4. L is 4. Can it be 4? Yes. M sub L. If L is 4, then m sub L can be from negative 4 to positive 4. And m sub L is 2. It falls in that range. It's good. The spin quantum number is either plus 1/2 or negative 1/2. In this case, it's negative 1/2. So yes, these can exist. This is why I'm telling you also, don't touch the periodic table. And this is why. Remember what L is on the periodic table. It tells us our block. If L is 0, then it's S block. If L is 1, it's P block. If L is 2, it's D block. If L is 3, it's F block. Well, in this case, these set of quantum numbers can exist, but L is 4. What's that? There's not one. That's my point. Don't try getting yourself to jump in and use that periodic table to tell you whether this can exist or not. Because if you're using the periodic table, you just answered no here, and this is 100% yes, it can exist. Let's go on to the next one. N is 2. Can n be 2? Yes, it's a whole number between 1 and 7. If n is 2, can L be 3? No, because L can only be from 0 to n minus 1, and n is 2, which means the greatest L can be is 1, so it cannot exist. No. Also had a problem here. Look at the spin number. Cannot be a plus 1/4. Let's move to the next one. N is 6.3. Can n be 6.3? No, it has to be a whole number between 1 and 7. So, no, cannot exist. Then you go to the next set of numbers. Look at the next set. You get n is 5. Can n be 5? Yes. If n is 5, can L be 2? Yes. If L is 2, can n sub L be negative 1? Yes. Can the spin quantum number be plus 1/2? Yes. So, those sets exist. Now, go to the next one. N is 4. Can n be 4? Yes. That's between 1 and 7 and is a whole number. Next, if n is 4, can L be 1? Yes, because that falls between 0 to n minus 1, with n being 4, 4 minus 1 is 3, so 0 to 3, 1 falls in that range. If L is 1, can n sub L be 1? Yes. And can the spin quantum number be negative 1/2? Yes. These sets of quantum numbers can exist. So remember, if you're determining whether or not they can or cannot exist, use the range estimate. It's that simple, okay? Now, your next set of questions ask, give me the 4 quantum numbers for the following elements. Remember that thing I told you to put to the side? Now pull your periodic table off. Here's my periodic table. Here's the thing. You guys have this thing broke down, and if you don't know how to break the periodic table down, you might want to know that. So that this moves a lot faster for me, I'm going to go ahead really quick and break this down. For myself, give me 1 second. There's that. Let's remember, break these things in half. There's a halfway point here. This is plus 1/2. I made it look really awful. I'm going to clean that up. Sorry about that. So we cut this in half, and this is positive 1/2. And the second half over here is negative 1/2. Find the halfway point. P block. Split it. Remember, this is plus 1/2. This over here is negative 1/2. Split the D block. This is plus 1/2. This is negative 1/2. Down here on the bottom in the F block, split the F block, and this is plus 1/2, and this side is negative 1/2 for that spin number. Okay, so using this periodic table, we are going to try and find the 4 quantum numbers for barium. So here's what I'm going to do. I'm going to start with barium. So I find my element, and right here's my element, barium, circled in green. So here's the thing, start with L. So barium is in the S block. And remember, for L, 0, 1, 2, and 3. 0 is for S, 1 is for P, 2 is for D, 3 is for F. So, barium is in the S block, which means L has to be 0. So, look at barium now. So, for barium, I'm trying to find N. For S block, N equals rho. So, I'm trying to get that energy level N. So, I have 1, 2, 3, 4, 5, 6, 7. Remember, down here at lanthanides, actinides, this is 6 and 7. There's rows. Barium is in the 6th row, and N equals rho, so 6 for N. N sub L, we labeled our periodic table, so just go up there. The orientation is 0. And the spin, negative 1/2. That simple. Okay? So let's move to chlorine. So I'm going to chlorine. Let's go over here to chlorine. Chlorine's atomic number 17. Here's chlorine. First thing, chlorine. Let's see. Chlorine is in the P block, which means L is 1. So for P, you also have that N is equal to the rho. So I'm trying to find N for chlorine that's equal to the rho. So I'm in the third row, so that means N is 3. M sub L, orientation, go up, 0. And spin, -1/2. Let's move to nitrogen. So looking at nitrogen, nitrogen is atomic number 7. Nitrogen is in the P block, so that means L is 1. Remember, for the P block, N equals rho, so N is equal to the rho that nitrogen's in. Nitrogen's in the second row. M sub L, you follow nitrogen up, it's a 1, and it's in the +1/2. It's in that first half. So now, let's go to do iron. So, iron, Fe, atomic number 26.
Jada Martin to the office.
Here's iron. So, iron's in the D block. Now, this is a thing to remember with D block. D block, N equals rho minus 1. So, I'm in the D block. It means L has to be 2. And N is rho minus 1. Well, iron's in the fourth row, but I got to subtract 1 from that, so that's 3. And follow that up, iron is in the -2 orientation. And it's in the second half, so -1/2. Hopefully you're getting that. Alright, let's look at plutonium. Plutonium is atomic number 94. So plutonium is all the way down here in the actinides. So it's in the F block. So remember, for F block, the N is equal to rho minus 2. So we're in the F block, so that means L has to be 3. So then plutonium, I'm trying to get N. N is equal to the rho. N equals rho minus 2. So remember, this is the 7th row. Because remember, these actually fit right here on the periodic table. So this is the 7th row. So 7 minus 2 gives me 5. And then M sub L, just follow it up, it's 2. We're in the first half, so +1/2. Now this next one is a trick, and I use it on here to make it fresh in your mind. Helium, atomic number 2. You got to remember something with helium when you're doing electron configurations and you're doing quantum numbers. Helium doesn't sit here when you're dealing with that. Here's helium right now, but helium sits there because it's a noble gas. So what we need to do is helium actually comes over and sits here right next to nitrogen. So, helium is in the S block, so it's 0. So it sits over in an S block. So that means it's in S block, so L is 0. And remember, for S block, N equals rho, so N is in the first row, so 1. Then M sub L, it's in the 0 orientation. And then it's in the second half, so -1/2. So that's a really good one. It's a really good trick question. It's probably the only trick question you can really see on here that I can throw at you guys. So moving now to technetium. So looking here at technetium, you got to find technetium on our periodic table. Technetiums are right here, atomic number 43. I'm so sorry I didn't include those atomic numbers on that on here for you guys. I'll fix that later on. So technetium's in the D block, which means L must be 2. For D block, N is equal to rho minus 1. Technetium's in the 5th row, so 5 minus 1 is 4. M sub L is stacked on the 2 orientation. And it's in the first half, so plus 1/2. So that's how to get the 4 quantum numbers for elements. Breaking it down. Alright. So now we're going to do it the other way. These next questions here, flip this and take us going the other way. So this is where you have to be able to go, you have to be able to find the 4 quantum numbers, and with the 4 quantum numbers you have to be able to find an element. So you're going to follow the same set of rules, just a couple little differences. So let's start. So first here, remember, always start with L, because L is going to tell me a lot. So let's look at L. L is 2, which tells me I'm in the D block. So D block. This is what's important with the D block. I now have N. I'm trying to find the row, because what I've done is I've narrowed it down between columns 3 and 12. But I have the D block, and I have to remember something. With the D block, when I'm trying to find a row, I just got to do the opposite of this, where N equals rho minus 1. The row will be equal to N plus 1. So everything, look, that right there is that subtle change I was talking about in preferences that you're going to see. Just a very subtle change. Not a massive change, very subtle, very light, but hugely important. Because we have to follow that if we plan on getting the right answer. So let's go on here and look, I'm in the D block, so I have to add 1 to that N. So 4 plus 1 tells me 5th row. So I'm now looking at the 5th row in the D block. So here's the 5th row in the D block. So here's all these. So this is what I've done. I've narrowed it down to these right here. Oh, sorry, went a little far. I now have it narrowed down to those 10. To narrow it down even farther, what we're going to do now is look at M sub L. M sub L is 1. So that tells me this is either the 6th or the 11th columns. So I've now narrowed it down from there to here, molybdenum, or here, silver. So the only thing to differentiate them now is the negative 1/2. So it's the second half, which tells me second half, which tells me the second column. So it's the 5th row, 11th column, which is silver. So AG. Please do me a favor. I know a lot of you guys, I was putting those atomic numbers on there for you guys. I really want you to put those chemical symbols. I'm going to stress it to you on the quiz, but you have to put the chemical symbol. It's already there for you. Just make sure and match it. Alright, so let's move to the second one. I'm not going to write as much on it, so it's actually legible. So the second one, L is 1, which means P block. So I'm dealing with P block. Remember, for P block, N equals rho, which rho equals N. It's vice versa. It doesn't matter. So I'm in the P block. I've narrowed it down to here. So I've got all P block there, but now I'm in the third row. So 1, 2, 3. I've narrowed it down to these guys. So third row. 1 orientation, which tells me 15th or 18th column. So I've narrowed it down between phosphorus and argon. So then the plus 1/2 tells me the first half, which tells me this is phosphorus. Atomic number 15. First half. Alright? So let's move to the next one. I'm going to pick up the pace a little bit. Bell's getting ready to ring on me. So 3 tells me that this is F block. And with the F block, it's important to note, F block, N was equal to rho minus 2. So when I'm trying to find the rho is equal to N plus 2. So I'm going to look at the 5th row, 7. So I add 2 to this. It tells me 7th row. So I'm in the 7th row. I'm here in the F block, and I'm at the -3 orientation. So I'm here between atomic number 89 or atomic number 96. -1/2 tells me the second half, so I know I'm right here with, I think it's curium, so Cm. Remember that rule there. That right there is that subtle change I was telling you about. So picking up the pace a little more. Looking here, L is 0, which tells me I'm in the S block. So I'm in the S block. N equals rho, so rho equals N for S block. So I'm in the 7th row. 0, 0, -1/2, the second one, so it's radium. Ra. Going from there, L is 2, that tells me D block, which means N is 3, so I add 1 to that because the rho is equal to N plus 1. That's 4th row. So I'm in the 4th row, D block, -1. So it's either atomic number 22 or atomic number 27. So it's titanium or cobalt. In this case, it is titanium. Going from there, L is 2. Since L is 2, it tells me I'm in the D block again. N is 5, so I add 1 to that because rho equals N plus 1 for D block. I'm in the 6th row D block, and I'm in the 0 orientation, so it's atomic number 73 or atomic number 78. It's the -1/2, so it is atomic number 78, platinum. Last one, L is 1, which tells me P block. Since I'm in the P block, it's the 6th row because N equals rho, so I'm in the 6th row, P block, 0 orientation. Tells me it's either lead, atomic number 82, or atomic number 85, astatine. And plus 1/2 tells me first half, so it is lead, atomic number 82. Now, a lot of you are probably going to wonder, okay, what's up with these random 4 questions here at the bottom? It's pretty straightforward. I put these on this practice sheet for a reason. Because we did a lot of working problems here. This quiz isn't going to be just you working problems. You should know me better than that. In this quiz, I'm going to ask you questions on concepts as well. And these are straightforward, but be able to answer things. You need to remember rules, things you did. You've got to not only know how to work the problems, but know concepts and things that led to these. So, these are very straightforward, low-level questions. If I give you something like this on the quiz, it's a give you question. Like, what are these quantum numbers? So, N is the principal quantum number. L is the angular momentum, I'm trying to rush, number. M sub L is the magnetic quantum number. I'm rushing so much I forgot quantum there. Gosh, this is awful. M sub S is the spin quantum number. So this is the thing. You not only need to know what these things are, what they show us, what they tell us. Know information about them. Alright? If you have any questions, please feel free to come try and ask me. Message me. In the morning, I may be helping set something up in the auditorium. Just a heads up. But if you got any questions, just come ask. Besides that, you guys are going to kill it.